Good morning, everyone, and welcome to the November 2024 edition of the Southeast Monthly Climate Webinar, where we talk about the climate and special topics pertaining to the Southeast region. My name is Chris Furman. I'm the Deputy Director of the Southeast Regional Climate Center, and I'll be giving a climate overview of the past few weeks. Our other speakers today are Todd Hamill from the Southeast River Forecast Center, who will provide a water resources update, Pam Knox from the University of Georgia, who will provide an agricultural impacts update. And joining us this morning, we're pleased to have Michelle LaRue from the Climate Prediction Center, who will be giving us an update on the El Niño-Southern Oscillation and discussing the upcoming winter outlook for the Southeast. So again, thank you all for joining us. Just a reminder to type those questions and comments into the question box at any time, and they'll be answered at the end. Also, a recap email of this webinar will be sent out with a YouTube link to the recording in the next day or so. All right, so let's get started with an overview of the climate. Are the slides moving? There we go. All right. So temperatures. All right. So over the past several weeks, we see the temperatures have been well above average across much of the region, especially from the northern Gulf Coast up through Alabama, Georgia, and Tennessee, where many locations were more than 10 degrees above average. Most other locations have been running between 5 and 10 degrees above average since late October. In all, numerous locations across the region are on track to record record or near record warmth for the month of November. On the other hand, the heat that had been quite persistent across the Caribbean was replaced with temperatures that were a bit closer to average. You may recall last month that we were tracking the number of days with temperatures of at least 90 degrees in San Juan. Well, on October 28th, San Juan ended its streak of 50 consecutive days, which is now the longest such streak on record since 1898. That broke the previous record of 36 straight days back in 2012. In addition, San Juan has recorded a total of 176 days this year with a temperature of at least 90 degrees, and this breaks the previous record of 172 days that was set back in 1983. Okay, next slide. Looking at precipitation, we can see that many locations were near normal over the past several weeks, though areas of dryness were scattered across the region. The most notable exceptions were found across eastern portions of Georgia and South Carolina, where deep tropical moisture out ahead of Hurricane Raphael interacted with a frontal boundary, producing widespread totals of 4 to 8 inches, with some locations near Orangeburg, South Carolina, and Valdosta, Georgia, recording over a foot of rain between the 6th and 7th of November. It was also quite wet across the Caribbean. San Juan recorded nearly 17 inches of rain over the past 3 weeks, which is over 3 times the expected amount. Several CoCoRaHS gauges on St. Croix have recorded over 8 inches of rain since the beginning of the month, while gauges on St. Thomas and St. John have recorded over a foot of rain. That's more than double what they expect on average for the entire month of November. Okay, next slide. The return of some much needed moisture over the past few weeks meant that several notable dry streaks that we were tracking last time came to an end. You can see from this table that several long-term stations in the region recorded their longest or one of their longest streaks of consecutive days without measurable rain on record, many of which extended over 35 days. New all-time records were set at Washington's Reagan Airport, Norfolk, Virginia, and Augusta, Georgia, while places like Lynchburg, Virginia, Atlanta, Georgia, and Athens, Georgia recorded their second longest streak on record. Okay, next slide. So looking at the drought monitor, we've seen an expansion and intensification of drought extending from the northern Gulf Coast through the interior and northern portions of the region, as well as eastern portions of the Carolinas and Virginia. Areas of extreme drought have emerged across parts of Alabama and Tennessee, while severe drought has emerged across extreme eastern portions of Virginia. We also saw abnormal dryness emerge across the eastern panhandle of Florida, central and even western parts of North Carolina, which are still recovering from Helene, and much of South Carolina. Small pockets of abnormal dryness, which had popped up across coastal sections of Puerto Rico, have been eliminated over the past couple of weeks. Okay, next slide. So we still have a little less than 2 weeks left in the hurricane season, but if we don't see any further activity, then we'll end the season with 18 named storms, 11 hurricanes, and 5 major hurricanes. 7 of these storms, including 4 of the 5 major hurricanes, impacted the southeast region, including Puerto Rico and the U.S. Virgin Islands. The number of named storms, as well as hurricanes, major hurricanes, they're all above their 30-year averages. And the accumulated cyclone energy produced over the season is running about 135% of normal, which according to the CPC puts the season in the above normal category. Okay, next slide. So normally we would cover the monthly and seasonal outlooks, but because our webinar this month is a week earlier than normal, these outlooks will not be available until Thursday. So please check this link here in the next few days for the updated monthly and seasonal outlooks. Michelle will talk a bit about the upcoming winter season in the context of ENSO in her presentation here in a few minutes. Having said that, the seasonal outlooks for the Caribbean are available, and they continue to advertise above average temperatures and precipitation across the region over the next few months. Okay, next slide. So looking ahead over the next week or so, we see that parts of the Gulf Coast may get between, and they're already getting between maybe 2 and 4 inches of rain, most of which will come in the next few days as a cold front approaches the region. This should bring some drought relief to southern portions of the Southeast. Western portions of North Carolina and Virginia, as well as eastern portions of Tennessee, may also see some snow later this week. Okay, next slide. Looking ahead to this weekend and early next week, above average temperatures are favored across the entire region, with above average precipitation across the interior part of the region and below average precipitation favored across the Florida Peninsula. Next slide. Okay, if we look out to later next week, this includes the Thanksgiving holiday. We see a continuation of above average temperatures with above average precipitation expected across nearly all of the region. And finally, on the next slide, we look out, there we go. If we look out to about mid-December, we see more unseasonably warm temperatures favored with equal chances of above or below average precipitation, except across the far western part of the region where above average precipitation is expected. Okay, next slide. Should be the summary. All right, there's the summary for you to look over after the webinar. Also want to acknowledge our service climatologist, William Schmitz, who helps compile much of this information every month. So thank you so much. And with that, I'll turn it over to Todd for our water resources update.
Thank you very much. So we'll go ahead and get to the first slide. I can report that it is raining in Peachtree City, Georgia, because we are getting poured on, and this has been a site that we haven't seen a whole lot. So we'll talk a little bit about that as we go through this. If you look on the left side of the screen, it shows the USGS and the 28-day average stream flows for the Southeast, and you can see out as where we saw some of the drought areas that were shown in there, we can see the stream flows are also very low in some of those places. And that includes Mississippi, Alabama, parts of the Florida Panhandle. And as you move further east and up the coast and down into Florida, you can see that we have a lot of normal and above normal in those areas. The rivers and the reservoirs are a lagging indicator in a lot of our drought instances. And so you'll see it, because even though we're starting to drift into drought during this time of year in some of those areas, some of the stream flows are a little slow to react, only because we have had significant rainfall. And as we look on the right hand side of the screen, and we see the last couple of years of the stream flows across the Southeast, one thing you'll notice, and one thing I've noticed in the last year or so, is it really truly has been feast or famine. We have gone from very dry to very wet. We've gone back and forth a lot this year, and in different parts of the Southeast. We'll see it when we look at each state in just a little bit. But you can see that we really have we've either been really dry or really wet, and it's been very pronounced this year, or so it seems anyway. Because even back into last November, we were talking about significant drought at that time, but we knew that there was an El Nino coming up, so we were not concerned about it as we went into the winter, as we thought we would get rainfall during the Southeast. And so we have seen that. The difference this year is right now, for the Southeast as a whole, we are seeing we're about near normal, right in the middle. But now let's go to the states. So let's go ahead and go to the next slide, and we'll look at the smaller picture of each state, and we'll start with Alabama. And you can see that, again, this is one of the things we talked about, where we would be early in the summer, we were above normal. And then as we went through the summer and had dryness, and then tropical season came in, and we've had a couple of events that have brought things out of normal or into normal from very dry. And we are now back below normal. So it's gone back and forth a lot. You can see that in Alabama. You can also see that in Georgia. As you look at the middle slide, and you can see how quickly we've gone up and down during those times. Having a whole October where much of the state had zero rainfall really had a big impact in the area, especially in Atlanta and the northern parts of the area. But we finally started to receive some rainfall as we go from the fall tropical weather type season into our winter season. And then Florida has been exceptionally wet, as we've seen from Milton back earlier in the year. But they also, even before that, had a pretty wet summer going into what was Milton that produced all that rainfall in those areas. And so we continue to see flooding in Florida, and will still continue to last for at least a few weeks as they go into their dry season. So let's go ahead and go to the next slide, which will move up the East Coast a little bit. And South Carolina, again, same story, where we've seen dryness. We've kind of gone back and forth. They are now in kind of the normal category. And so they're in decent shape, even though they're starting to see some dryness, especially at the surface. The short-term indicators are starting to indicate some of the dryness. North Carolina has been extremely wet, and even in the last, that South Carolina, North Carolina, the most recent rainfalls, we actually had some record flooding along the coast, both in South Carolina and Georgia, from that recent rainfall that happened near Orangeburg and in those areas, and we are still flooding there in a couple of those areas. And then we get up into Virginia, and Virginia, we don't cover all of Virginia, we only cover the south part of Virginia, so most of our area has stayed pretty normal, but a lot of the northern Virginia was very, very dry for a while, and then got very, very wet. And again, now they are slowly starting to get some rain, but they are still dry right now as we go into our recharge season. So let's go to the next slide, which just shows where we are with respect to current flooding conditions. And you can see that even though, last week we ended up with some heavy rainfall, and it is finally getting down to the coast in South Carolina and Georgia, and that we're over in the Panhandle, we're expecting some action stage rises and minor flood stage rises. So we are seeing some maybe movement in that because of the heavy rainfall that's moving into that area. And you can see in Central Florida, we've had weeks and weeks and weeks of flooding in the St. Johns Basin and the Withlacoochee Basin, and that will continue at least for the next couple of weeks in some of those lower end points. And so we continue to stay in flood in those areas. So let's move on to the next one. And this is looking at our climatology, and we're in week 46. So we've kind of come out of our lull of the in-between stages. So our in-between our tropical season and our winter flood season, we're starting to transition. And I will have to go back, and I'll probably bring this up at some point. I'm not sure exactly what happened in week 46 during our history. I'll have to go back and research that, but something happened during that time, both in Florida and in the rest of Southeast, that brought us some floods during that time. But this is really kind of the time that we start to transition into our winter flood season, our winter recharge season, out of that tropical season. And so that's why you see the ramp up of some of the flooding in the Southeast. And so this is for the Southeast as a whole, but let's look at the next slide, which is Florida. And while it remains in flood right now, and that's because of what happened during tropical season, we really do come to kind of a quiet time of year, the dry season there. Again, the reason you see some of the floods during that time is typically during an El Nino year. And right now we're looking at a La Nina year. And so we're not expecting any flooding during that, or any additional flooding to what we've already had. So it looks like they're going to get a much needed break through the winter to finally recover from all the rain they've seen. So let's go to the last slide. And this is just my last slide. And this just kind of talks about, we're really looking at normal risk for flooding. We're, again, as mentioned, we're a week early before we get our CPC forecasts. And we know that there's a La Nina week, and we know that there's some dryness, but I'm interested to see what Michelle has to say in just a little bit, because it looks like a weak La Nina. And many years we've had we've been near normal during those times of year. So we just have to be real careful. And we're kind of on the cusp of being dry in the western portion and wet in the eastern portion and still wet in Florida, but we still have a normal risk for flooding. I think that's what we're looking for this winter at this point. And just because we do get floods during that time of year, and it wouldn't be unexpected. So we are expecting to get some flooding, but it doesn't look like it will be the significant flooding that we have seen, especially during our tropical season. And so the last slide is the overview slide, and you can read this later on, and I will go ahead and pass it off to Pam.
All right, well, thank you, Todd, and good morning, everybody. It's raining here in Athens too, and I'm happy to see it, although not all the farmers are happy. We'll talk about that. So let's go right into it. Some of the impacts of recent conditions on agriculture. Even though it's overall dry, you know, we have these really heavy rains with no rain in between for a long time, and that's really hard for farmers to deal with because the plants need to have regular sources of moisture. And so it's caused a lot of problems for farmers this year. I talked a little bit about it last week in our review of the growing season, which isn't finished yet. We'll talk a little bit more about that in a minute. Some areas are so dry that farmers have just given up on trying to plant winter forage and crops for this year because if you don't have any moisture, the seeds won't germinate and you've just wasted the seed then and the labor and the cost of running the tractor across the field. And we're getting so close to the end of the growing season that they just really don't have time for plants to establish at this point. The result of that is a lot of livestock producers are feeding hay. You know, this is hay that's supposed to get them through the winter. They're already feeding it now, so either they're going to have to cull cattle or they're going to have to purchase hay from somewhere else to try to get through the winter. And so that's something that livestock producers are really watching. We did have moisture from rain in the last week or so, and we're going to get more this week. That has been a lifesaver for peanut harvesters because the ground was so dry that they couldn't break the crust on top of the field to really pull up the peanuts, and so they've been able to get a lot of that harvesting done. And some winter planting has taken place in places where they think they have a long enough time before frost to get the crop established. The lack of the frost this year has led to a lot of regrowth of cotton and peanuts. You know, they've already gone in and done the harvest, but the plants are still there, and without frost, they keep growing. And so nematodes and other pests are continuing to feed on the remains of those crops, and they will last in the fields until we do get frost. That's going to affect how farmers manage their crops for next year because they're going to have to figure out what kind of chemicals they need to use to keep the yields up and keep the pests down. And there's been also a lot of strawberry plants, especially in South Carolina, and I'm sure in Florida as well, being planted and producing, and that's a lot of the winter crop. There have been some instances of fungal diseases and so on from that, but overall, I think the crop is looking pretty good. So let's go on. Soil temperature has been way above normal for the last week or so. Not surprising considering the air temperature has been so warm. And so that is something, and because the soil is also pretty dry in many parts of the region, that's not a surprise. Soil moisture on the right-hand side there, that's the top meter, so that includes the remains of some of the tropical storms we had, like Helene and not so much Milton, but even Debbie is still showing there. Whereas in comparison in Alabama, where they have not gotten any of that rain, it's much drier through that profile. If we go on, the chill hour accumulation, you know, we've got fruit farmers that are starting to look at winter chill. Usually it starts counting in the beginning of October. So this is a chill hour calculator for our station in Peach County, Georgia, which is pretty close to Macon, right in the middle of the Peach Belt in Georgia. And you can see, because of the warm temperatures this year, the chill hour accumulation is a lot below the long-term historical average. That will probably go up as we have some cooler air coming into the region. But it's a real concern this year because with a La Nina, we do expect warmer than normal conditions, especially in the southern parts of the region. A little less likely as you go farther to the north. but that's going to be a concern going into the spring. So we'll be keeping an eye on that over the winter. If we go on, the lack of freezing conditions, we have not had frost in most of the region yet. You know, last month I talked about the growing season and how it's still going, and it is still going now. You know, most of the crops aren't really growing at this point, but there's still nothing to kill off the remains of the plants in the field. You can see the little pictures there show cotton and peanuts that are still blooming in the fields, even though the harvest is done. And really, in the last month, we have not had freezing temperatures anywhere except for the higher elevations of the Appalachians and then far northern parts of Virginia. And so the growing season is going to continue. And if we go on to the next slide, people are asking, when are we going to get a freeze? And, you know, I look at the forecasts from GFS and other places from tropicaltidbits.com. This is the best chance of frost. And this is a ways down. I mean, this is for November 30. So this is right at the end of the month. And it shows that according to the current model, keep in mind, this is still a ways out and it could likely change. We should see a pretty widespread frost right around the end of the month. And so if that model turns out to be accurate, then I think that will give people some relief. But you notice that, you know, most of Florida and southern Georgia and along the coast in the Carolinas and even in southeast Virginia still are not expecting to get frost. And so that's something we'll have to keep in mind. On the next slide, I show frost dates. The average frost date is listed there. We're in the bright green this week as November 19. So you can see the average first frost date for a lot of the region, especially along the Piedmont there, is this week. And so we're going to be later than average for a lot of the region. 90% of the years on the right-hand column there, 90% of the years, well, now I'm getting confused. It's been a long day. Anyway, so we do not expect frost until at least November 30th or even later as you go farther to the south. Of course, in Florida, you got to keep in mind some areas in Florida don't really get frost at all, or they get it much later in the season. So it's not surprising that their first freeze dates, the average should be quite a bit later, even into the end of December. And we'll be watching that carefully to see what happens with that. So let's go ahead. And this is my summary slide. You can look at that later. And now it's my pleasure to introduce Michelle Leroux to talk about El Nino, Southern Oscillation, and what we can expect this winter.
All right. Thanks so much, Pam. Always great to get that perspective. And I really enjoyed the earlier talks. Thanks again for having me. It's always it's just great to be able to talk to this audience. I sit at a national center and sometimes it can be a little bit of an echo chamber. So I really appreciate these opportunities to go out into the field and talk to more regional and local folks. So thank you. So I am at the NOAA Climate Prediction Center. We're located within the Weather Service, and I am the ENSO team lead. ENSO is a term, an acronym. We like our acronyms that refers to the El Niño-Southern Oscillation, which is the both warming of El Nino and cooling of La Niña. And then there's also this middle ground we call neutral. So I know a lot about ENSO. I've been doing it for a number of years. I am not a seasonal forecaster. There's a separate team that works on the winter outlooks for temperature and precipitation at CPC. I will be showing those maps today, but just keep in mind, I really, my gig is ENSO, and I really want to credit those folks you see there on the slide. They keep me in line. It really is a team effort that leads to this product. Okay, so we have an ENSO alert system. It's pretty simple, not a whole lot of categories. Advisory means that we're in an El Nino or a La Nina. It's here if we see it. Watch means that it's not here, but it looks favorable. And not active just means nothing applies. And right now we're in a La Nina watch. We've been in a La Nina watch for a while. We issued it earlier this year. At the time we issued it, we thought the formation would be sooner. We were anticipating like a late summer onset, and that's, you know, now it's November, we're still in a watch. So clearly those earlier forecasts were not as accurate. But we still think this will emerge. If we do, if it does emerge, it's gonna be, you know, just barely. So it's right now we have a 57% chance of La Nina emerging in October, November, December. We always refer to these 3-month periods that we call seasons. So that's the upcoming season, 57% chance. It's not 100. You know, there's still a decent chance it will not form in that season. So if it forms, it is expected to persist through January, February, March of 2025. But again, we're still in a watch, so no onset or evidence of onset yet. This is a schematic of the tropical Pacific Ocean. The top left there is neutral, or the normal state. And what you see in that neutral plot is that typically closer to South America, you have a cool upwelling zone. And then over in the Western tropical Pacific, it's warmer. You tend to have more convection and precipitation over that Western tropical Pacific, and sinking motion over South America. And I always you know, talk about La Nina basically being an acceleration of that pattern. So it's just taking the neutral pattern, and now if you look at the bottom right, it's just basically that same pattern, but even stronger. So you have more cold water upwelling off the coast of South America, more warmth over the Western Pacific, more precipitation over the Western Pacific, more sinking motion in the Central and Eastern Pacific. And it's this whole cycle that will essentially impact the jet streams over the North Pacific Ocean. Those jet streams, you know, they essentially get perturbed, so the jet moves more poleward, and it can lead to cascading effects on the United States. So when we diagnose the ENSO situation, we're basically staring at the tropical Pacific, all right, and the equator in particular. And so this is showing sea surface temperature anomalies, and the reds there are where it's above average, and the blues is where it's below average. And you can see, at least from the October 2024 snapshot, that we do have evidence of an emerging La Nina. We just haven't yet seen it hit our thresholds that we need to declare the onset of La Nina. The other thing to notice is just there's a whole lot of ocean warmth, all right? And we do have some questions about how much that ocean warmth may actually be maybe delaying this event. Anyways, at this point, when we look at a little bit finer resolution, these are sea surface temperature anomalies again, with blues being below average sea surface temperatures, and the oranges and yellows and reds are above average. And when you look at this on a week-to-week basis, there's a lot of noise. This is kind of a messy plot, but generally you see the formation and development of that La Nina. In the last week, it actually did weaken a little bit. This is normal. We tend to see these little up and downs as we go into an event. At this point, we again still expect it to form. So this is a region that we focus on, the Niño 3.4, and the reason we focus on it is that it seems to be strongly related to the tropical circulation above it, and as such, we tend to take this box, we average the sea surface temperatures to create a time series. And so this is a time series of that Niño 3.4 region, and each line is a different La Nina that has occurred since 1950. All right, I think there's like almost 25 La Ninas in our historical record. And anything below minus 0.5 is our threshold for La Nina. Sorry, I didn't draw it in here, but you can see most of these dipping down into our La Nina thresholds. The current evolution, so this is so far this year, this calendar year through October, is really right on the fringe. All right, so this is definitely, at least from a sea surface temperature anomaly perspective, we're just barely, you know, in distance of a La Nina. This is subsurface temperature departures. So now instead of looking at the surface of the ocean, we're looking below the surface of the ocean in the tropical Pacific. And this goes down to about 300 meters below the surface. You think of South America being over here, and Australia and the maritime continent over here. And again, cooler are the blues, warmer are the oranges. And what you see is the sort of the thing to take away here is there's a very fixed region of below average temperatures in the Eastern Pacific. That really hasn't budged. There's obviously some movement from week to week, but it's really largely just fixed there. And that's important because this is essentially our supply. I think of this as like the gas tank in the car for the surface. So it's very hard to get the surface cool if the subsurface isn't also cool. So we still see that supply, which is one reason we're still banking on this very weak La Nina to form. All right, this is looking at the basically the cloudiness and rainfall above the tropical Pacific, because remember from that schematic, there are shifts in the tropical rainfall, and those are important because again, that is the thing that will eventually impact the jet streams in North America. And at the bottom here is like the typical weak La Nina situation where you have drying and less rainfall over the central and eastern Pacific, and then you have wetter conditions over the maritime continent. And we are already seeing hints of that. We see wetter conditions in this region and drier in this region. It's not perfect, never is perfect, but there's already some hints in the atmosphere of a weak La Nina. Okay, so this is the ENSO outlook. We updated this last week. And the blue bars here are the probability for La Nina, again, 57% in this coming October, November, December season. And then it jumps up to about 74% during November, December, January season. This is normal. Typically, El Nino, La Ninas maximize peak during these winter seasons. And then we're expecting essentially a transition back to neutral by February, March, April. This is another tool. It's not so exciting to look at right now. This gives you an idea of intensity in that Niño 3.4 region. Again, our threshold is minus 0.5, and you see our probabilities for La Nina here. But it says, okay, well, what's the percent chance that it'll actually be less than -1 versus minus 0.5? So the chances of being less than -1, which is roughly a moderate strength event, are actually pretty low at this point. There's basically 1 in 5 or 1 in 4 chance that it would at least be moderate. So we're banking on that weaker strength. Okay, this is the thing that you guys are all here for, which is why, you know, what might this La Nina or potential La Nina do for the southwest eastern region this winter? So here's the schematic, and I have a love-hate relationship with the schematic. Schematics are great because they summarize information in one map. I hate it because you don't see the variability from winter to winter. But this is generally what La Nina does. It helps shift the jet stream to the north. Typically it's down here, and here it gets shifted to the north. That brings wetter conditions roughly across the northern tier, Ohio, Tennessee Valley, Pacific Northwest. And because the jet stream's shifted to the north, it tends to be drier and even warmer in the southeastern region. But there's a lot of variability about that, and I want to kind of show you that with some examples. So in these examples, I'm only looking at weak La Nina events. I'm not looking at the moderate and strong ones. So I'm just kind of throwing those out for now. And this is the typical or expected El Nino, sorry, this is a typo. This is clearly copied from last year. This should say La Nina, all right? Just like the title should be La Nina. So this is a typical La Nina precipitation pattern. Tends to be drier over the south eastern region. And here I'm going to just show you some examples from the past of weak La Niñas that tend to match this overall. And I'm almost randomly picking these. There's really no special reasons for these years. I think I was a little partial to more recent years. I wanted weak La Niñas that roughly fit this pattern. And you can see those here. Here's a 67, 68 event. And then actually more recently a 22, 23. So you can see that's not as great of a fit, but it is within distance of what kind of pattern you can expect for a weak La Nina. So the majority of cases tend to be, and these are not all the cases, I should add. Majority of cases tend to better fit this pattern, but there are a lot of outliers during weak La Nina. This is a case 83, 84 when we had a weak La Nina, and it looked actually like El Nino. I mean, it looked opposite of what you would expect. Here's a case where there was little match at all, just kind of a mess. You know, there's just some wet, there's some dry. It's sort of a bad match. So I can actually assign a score, a number to each of these years, all right, and say how well does this map match this map. And so I get a number for each case, and I'm going to show all the numbers here in this plot. I know this is a little busy, but I think I can walk you through this. The y-axis is showing that match score, the typical, again, ENSO pattern. All right, so if it matches, if the dots are in this top half, that means it matches better with El Nino. And if it matches better, or if the dot is in the bottom half, then it matches better with La Nina, all right? So those examples I was giving you was actually for something in here. I'm sorry, the x-axis here is showing the strength of La Nina and the strength of El Nino, okay? And this winter, remember I said it was probably gonna be a weaker event. So I drew this range here, and this is the most likely strength this winter, all right? So these are essentially years that are all comparable to what we may see this winter. And what you should see straight away is that more of the dots are in this bottom half than in the top half, all right? So that means more of these years are gonna match with that typical La Nina pattern than the top half. However, as I pointed out, there's some really egregious, big differences with the expected pattern. I showed you this dot 84 here. So this is that dot. That's the one that looked more like El Nino. And then I showed you this dot, which has had a very small match score. So it looked not like El Nino or La Nina at all. And then I showed you all these dots, which basically are here, okay, in these cases. So these are all weak examples. The other thing to notice is that the stronger the La Nina event is, the more likely you're going to be in this region, all right? So unfortunately, we do have to be alert to the possibility that we're going to have some busts this winter. All right, just simply because this is a weaker event. I think of it as the tropical Pacific is pushing onto the atmosphere, the global atmosphere, and the push is just a little weaker than normal. Ideally, you want a strong push, and you would see a more likely chance of those outcomes happening. All right. It's still more likely. There's more dots down here than up here, but it's not as likely as it would be for a stronger event. This dot, in case you're wondering, the star was actually last winter. It matched very, very well to what we would expect during an El Nino. So that worked out well for the Southeast region. Okay, so this is the outlook. Not surprising. Very La Nina-like for the Southeast region. You're going to be leaning below. There are some probabilities here around 50, 60%. Again, this is 3 categories. So anything above 33 actually means you're leaning dry. That's showing the favored category. So yeah, the more southeast you are, more in Florida, the more likely it is that you will have below average precipitation. And then for temperature, again, leaning above or likely above. I should add, in case there are any users, that for JFM through March, April, May, there's actually this area of wetter conditions dips down here into Western Tennessee. So if you look at those maps, again, you can look for all seasons. They're all at this web page. And again, this updates this Thursday. So these maps will change. Check it out. And then so I'm getting toward the end of my talk. I do get this question a lot, even from the southeastern region, is what about snow? And we have an ENSO blog post here that we released in the past month showing these maps of La Nina winter snow. This is just weak La Nina winters, January, February, March. And what you can see in general is that in regions that do get snow, below average snow is usually more common during weak La Ninas. This is a frequency map. This is actually a count of how many of these years. There are only 9 weak La Nina winters. So we, just counted how many times we saw the below average snowfall. That's nice because you get some sense of the variability. Okay, so that wraps things up. Basically, we're not totally sure La Nina will form. If it does, it will be probably weaker. Again, weaker pushing means that the door is open for more of these busts and outcomes over the southeast that you might not expect. It's just the way it works. It is expected to be strongest in the winter, but keep in mind some impacts do linger. Even if the La Nina were to end in January, there may be some impacts going into February, even in March. So our maps do reflect that information. Again, leaning below average precipitation, above average temperature, and also please with your users, just keep in mind that these are all maps in terms of probabilities. We just don't have the certainty in climate prediction to give you 100% chances. So it's important to convey uncertainty to your users. All right, that wraps things up. Thanks so much.
Thank you so much, Michelle. My name is Meredith Muth, and I am from NOAA's National Integrated Drought Information System program. I'm having a little bit of technical difficulties right now in terms of showing my window, but I'll just keep talking, no problem. This webinar series is co-organized between the National Weather Service, the Southeast Regional Climate Center, and NOAA's National Integrated Drought Information System, NIDIS program. A summary of today's webinar and recording will be shared both via email and it will be posted on drought.gov as well. And let's see if I can get this. If you have any questions for our speakers today, please go ahead and add that into the question box. We will not be having a webinar in December. Enjoy your holidays. We will see you in January where we'll kick it off with a 2024 year in the review, which should be really interesting. As Todd mentioned, quite a bit of feast and famine in the Southeast. Also, just wanted to flag for you that a webinar survey will pop up at the end with just a couple of questions. Help us improve our webinar. Tell us what you would like to hear about in terms of our special presentations, and we'd be happy to oblige. We're going to move now into a few questions for our speakers. My first question will be for Michelle. How do you get the subsurface temperatures? Do you use satellites, buoys, etc.?
Yeah, that's a really good question. So much of what you saw there in that particular plot is a combination of a model that is, basically like a forecast model, like you would for a weather forecast, except this model is being constrained. And what is it being constrained by? It's being constrained by observations. So there are things in the tropical Pacific, like the TAO buoys, tropical atmosphere ocean buoys that sit out there and they monitor subsurface temperature. And that information is basically fed into these supercomputers, and the model does the rest. The model also assimilates the sea surface temperature information in general. So just having the sea surface temperature alone sometimes is useful to know a little bit about what's going on below the surface, but you do need to have observations that monitor temperature below the surface as well.
That's great. Thanks, Michelle. Next question will be for you as well. This is referring to your image that you showed of best matches, which, by the way, I thought your analysis and description was excellent in walking us through a fairly complicated issue. Is there a CPC website, so a website from NOAA's Climate Prediction Center, where those best match images can be obtained?
Not at this point. I actually code these up right before these calls. So it's not a product that updates on our website. It's just something I custom design for these calls. There is also, I should add, if you want to refer to these sort of scatter plots, you can of course refer to this PowerPoint, which is custom for the Southeast. But there's also a paper that was published earlier this year that's open access, so anyone can access it. It's in the Bulletin of the American Meteorological Society, and it does these scatter plots for all of North America. And you can refer and use those plots in that paper as well.
That's great. Okay, Michelle, this is a question related to that very famous visualization image that shows the dip of the jet stream and impacts across the United States. The question is regarding the prediction that Western Tennessee will probably experience the dip of the jet stream, causing that area to have increased precipitation.
Yeah, but not till later in the season. So December, January, February did not have that, but January, February, March, which is arguably also part of the winter, does have that. So the schematic is just kind of it's really just a broad brush portrayal of where the jet stream and these patterns set up. But for specific details, you really want to consult those Climate Prediction Center Outlook maps.
Excellent. And we will make sure that we have links to all relevant ENSO products and CPC products as well in our webinar recap. We don't have any more questions. I'll give it another minute. I'd like to see if any of our speakers have any other last comments. Okay, and with that, I think we're going to close off our 2024 year of the Southeast Monthly Climate Webinar, going into our 4th year. Huge thanks, of course, to all of our presenters, our regular presenters, Pam and Todd and Chris, and our special guest today, Michelle. Wishing you all a wonderful day. Thanks for joining us, and we will see you in January.
Thank you too, Meredith.
Thank you. Appreciate this. Good luck with your new position.
That's fine.